Hello to everyone. I am Dr. T. Ramesh, and in this video, I will clarify the doubts related to the principle of matter waves. Is de Broglie proposed matter wave theory is correct? If that is the case, why can't I see any associated waves while I am moving? According to the de Broglie, every moving particle is associated with a wave. That wave is having wavelength that can be measured by using the different formulas. There is a relation between the wavelength of the wave to the linear momentum of the particle that is expressed in terms of lambda equivalents to h by p. Here p is the linear momentum and lambda is the wavelength and h is the Planck's constant. So according to the de Broglie, if the particle is in motion, so wave is associated with it. So according to the classical theory, human is also a particle. If, for example, if I am moving with velocity v, but I can't observe any kind of waves. Why? Whether the theory is wrong or my understanding related to the matter wave concept is wrong. I need to check. So for example, when you take in the definition, a moving particle is associated with a wave. That wave is called as matter wave. Wavelength of the associated wave is called matter wave wavelength. And these are measured by using different formulas based on the data given and based on the situation. It might be lambda equivalents to h by mv or h by p or h by square root of 2me or h by square root of 2m capital V or h by square root of 3m kt. These are the different forms to measure the matter wave wavelength. For example, in case of human point of view, I take it as myself as an example. I use the formula to calculate the matter wavelength is lambda equivalents to h by mv. Here, h is the Planck's constant, 6.625 into 10 power minus 34 joule second. Mass is 75 kg and velocity, I can max my walking speed is 9 km per hour, but not always. I take it as maximum speed. So if you turn into the meter per second, this value is 2.5 meter per second. When I substitute all these values in the formula, I'm getting the answer lambda equivalents to 0.0353 into 10 power minus 34 meters. Very, very, very small value. That again, lambda is 0.0353 into 10 power minus 34 meter. But we are observing the matter wave concept in the microscopic particles like electrons and protons and neutrons. Why? So I will check in case of electron point of view also. In case of electron, the mass of the electron is 9.1 into 10 power minus 31 kg. For example, I take it as velocity of the electron is light velocity approximate, that is 3 into 10 power 8 meter per second. I use this data, I am getting the answer like lambda equivalents to 0.0242 angstrom. It is a measurable range. But whereas in case of human point of view, that is 0.03 into 10 power minus 31. So both are having very, very drastic difference between the wavelength values. In case of massive objects, the wavelength associated with matter wave is quite small. Hence, it is not visible to our eye. Wave nature of matter wave is not apparent in daily observation because of the very small wavelength of the matter waves. That's what I can't observe any kind of associated wave when I am moving. Thank you. Thanks for your support.